the idea of implicit differentiation. There's a function related to another function that we haven't even looked at its derivative yet. In fact, let me ask you this. I've asked you this kind of question before. If y prime was x to the negative 2, can somebody tease out what y must have been? So you see how this is a different question, right? This is backwards. Yeah, it had to come from x to the negative 1 for sure, right? Because the power would have went down by 1, so I just put the power back up by 1, right? And look, I know this can't be the answer because how would I take the derivative? Negative would have come down. Is there a negative here? Shit, so there must have been a negative here to kill that negative that wants to come down. Is everybody... So this is one possibility. It could be plus any constant I want because it would just die. But still, this is the main part of it. Is everybody cool with this? We've looked at this kind of thing before. Can you take the next step? Like, if y prime had been this, I want you to realize something here. Where would that have come from?
Divided by 2.
X to the 0.
Yeah, it would have wanted to come from x to the 0, but how do you take this guy's derivative? Wouldn't the 0 come down? So then you'd want to divide by 0? What the shit? So where does that come from? If that comes from something, you'd think that must come from something, right? All right, that's one thing. You guys understand what the problem is here. There's no way in hell... In fact, what is x to the 0? 1. And what's the derivative of 1? 0. So there's no way that that even gets to that power. There's no way in hell. There's got to be some kind of a bridge there. There's got to be something. And this should come from something. We wouldn't expect this to be so weird that no derivative equals that. That doesn't make any sense. All right. So I'm going to kind of give the answer right now, but there's a main function that we haven't talked about yet, about derivatives of it, that's related to something we have. Namely, it's the natural log. That's what I do. All right. We're going to kind of prove that, and I want you... It's a nice baby step into the idea. We're going to get into a bigger idea. So if I start off with, if I write y equals natural log of x, and I want to take this guy's derivative, well, I don't know what the shit it is. Can I rewrite the form? So what is it I'm trying to get? What is it? Can somebody tell me? What is it I'm trying to find? Specifically, I'm trying to find y prime. Or in other words, I'm trying to find dy dx, right? Is everybody cool with that? Everybody understand that is the problem, and I need to find this. Can I rewrite this? What's that way where you write logarithms? ln specifically. How can I rewrite this statement? Is there a way to rewrite this statement? I'm not sure. Y equals ln x. I can just rewrite it as many times as you want me to, Jeff, but in a different form. It would be... What's the base? What's the base? No, it's log. Common log has got a base of 10. Natural log's base is e. So it'd be e to the y equals x. In fact, that's the basic idea of logarithms. Log base 2 of 8 is 3 because 2 cubed is 8. So e to the y. Now, isn't y a function of x? Isn't that true? If I took a derivative of both sides of this with respect to what? With respect to x, because that's what I want. Isn't that a function inside of another function? Okay. So when I take the derivative, let me really be more formal than I normally am. What's the derivative of e to something? The derivative of e to something is e to that thing. And what's the derivative of y? dy dx. And what's the derivative of x? Doesn't this say dx dx? What's dx over dx? 1. See, the derivative of x is 1. We know this. And if you look at the infinitesimals as a ratio, it is 1. It's awesome. I know some of you guys are like, okay, he's playing around with shit. This is great. I've almost got dy dx. I just have to do what? Divide by this. But what was e to the y?
X.
So dy dx equals 1 over this, which is x. So the derivative of ln x is 1 over x. So the answer to this right. I want that part totally understood. And then I'll bring in a little bit of like over carefulness. I'll show you in a minute. It's not really over, it's necessary. But does that what we've done make any sense at all? This is really chain rule right here. I rewrote this so that my y of x, my function of x, is now in something else. I rewrote it. So when I take a derivative, I didn't know what the shit this was, but when I rewrote it, I'm like, oh, I know what that thing is. So I can take the derivative of this, but wherever I see a y inside of something, that is a chain rule. Y is a function of x. If it's in something, that's a chain rule. This is really too beautiful to believe. Now, of course, you guys got different adjectives for it, but think about it. This is nice. There's not a damn way we could do this. And do you want to use limit definition for this? No. So this is awesome. I can rewrite it. There's got to be some way to use this rewrite. And yes, we got chain rule. That's exactly chain rule. So now we can add the derivative of natural log as something we know. So now I can ask you a question like this. And this will be the last thing we do. We'll get out a little bit early. Find the equation of the line tangent to f of x equals natural log of x squared minus 1 at x equal to, it doesn't really matter, Jeff, it's going to be gross no matter what. X equal to, let's just say, 2. I told you a while back that you're going to see this question a lot. As you learn new derivatives, you're going to see this question again. It seems to be important. So I lied a little bit. We'll do one more thing. I'm evil already, so I might as well just do something. So what's f prime? Times, yeah, the derivative of the inside, so it's 2x. So what is the slope at 2? Yeah, plug in 2. So you get 4 over 4 minus 1. So that's your slope. What's the point we're working with? 2 natural log of 2 to the 2 minus 1 is 3. So I'm interested at the point x equals 2. It's not a point. To make a point, I get the y piece. Got to plug that sucker in. That's the point that I'm interested in. So whatever this curve looks like, that's the point that I'm interested in that sits on the curve, and I want to get the line that touches it right there once. Bam, touches it right there. It's got a slope of 4/3. Now it's just the y minus y1 business, right? Y minus the y piece equals m times x minus the x piece. So y is 4/3 x minus 8/3 plus natural log of 3. Woo-hoo. It's the exact answer. When I say exact, people often think that it's when you put that in you get decimal, but that's never going to be exact because it's got to stop somewhere. This is exactly what we've done before, right? You're just going to have different functions here answering the same kind of question. You find the slope the same way. Okay, last thing. I want to show you something interesting. Y equals square root of x. Let's find the slope of the tangent line at x equal to 4, right? Actually, let's find the tangent line. Find tangent line at x equal to 4. So if I follow the same steps to find this equation of any line, I need the slope and a point. So now that we're in calculus, we use calculus to find the slope. What's the derivative of this? X to the negative 1/2. I like it. Now what's the slope at x equal to 4? You plug a 4 in. Square root of 4 is 2. To the negative 1 is 1/2. 1/2 times 1/2 is 1/4. Is that cool? And what's the point I'm talking about? 4, 2. So you get y minus 2 equals 1/4 x minus 4. You get y equals 1/4 x plus 1. So now watch this. Yes.
For the points, you just choose any coordinates.
You mean this point?
Yeah.
So here's the problem. Here's the question, right? That's the question. So they told me to do it for an x value of 4, so I have to use the point 4, 2.
Like the 2 points.
So my function at 4 is 2, yeah. So it's got to be a point that lives on the function we're trying to find a tangent line 2. Yeah. So visually, here's 1, 1, 4, 2. So we're finding that tangent line. See how it makes sense that it's 1/4 slope? It's very...
For y prime, is that a 1 or what is that over the...
Oh, remember this weird notation where they just say this evaluated at x equal 4?
Oh, okay.
Yeah. If I would use f of x, I could have used f prime of 4. It would have been a lot prettier with 2f of it. Now watch. I know you've heard of like these human calculator crazy ass people that just keep this is a good approximation for values of square root of x near 4. The shit do I mean? So is 5 near 4? Yeah, especially because this is really, really close to flat. 5 is near 4. The function isn't going waha. So I mean, it's going. So I can go a little bit further away than normal and be okay. Now watch. Square root of 5 is approximately 1/4 of 5 plus 1. That's what we just figured out. This looks like this for values near 4. That's really what we just figured out. And what is 1/4 of 5 plus 1? It's 5/4 plus 1. 1.25 plus 1 is 2.25. What is the square root of 5? My hand is out of bounds. 2.23. Well, do you think that's a pretty damn good? Yeah, shit. So these crazy ass people that walk around with quick ways of. Now, if I wanted this, I want you to realize, if I wanted the square root of 20, this ain't gonna work too well. Bless you. Because at that point, it's a much different tangent line at 20. Right? In fact, let's try it. 1/4 of 20 is 5 plus 1 is 6. It's the square root of 26. We already know the square root of 20 is not 6. Do you guys understand? So it's only for values close. And how do you define close? Well, it depends on how far off you want to allow yourself to be. But in this case, 5 is definitely close. So it's one little trick that human calculator people do is they have a quick way of figuring out what a good, do I want to use 4? Maybe I want to use 9. Maybe I want to use 16. Something to build it around. Then they get the little form, and then they do it. And they get close enough to impress people or whatever. And so whatever. That's all they're doing is this. Is that decent? That's another way to look at a tangent line than what we've done before. It is how the function behaves near that point. I like it. Okay. Yeah, we're leaving very nice and early. Tomorrow I'll have the quiz graded. I'll have a little worksheet, group worksheet, and then we'll do at least one more section out of 3. And the next day is going to be review day for the test on that Thursday. Tomorrow I'll have the practice test too. Okay.